Welcome back. I'm Pernilla Berg. I'm your moderator for this Science Talk session, and I really look forward to today. What happens when we couple architecture and cognitive neuroscience, you may ask? So did I, and I invited postdoc Zakaria Djebbara from Create Aalborg University to be with me here today to answer those questions. Zakaria sees himself as a social sustainabilityist, as health and well-being of human lives are quite important. Architects are true designers of our lives, argues Zakaria. And with me today, we have Zakaria, who will join me now. Welcome, Zakaria. Welcome, Zakaria.
Thank you.
So for the next 45 minutes, with questions from the audience, you and I will have a science talk, diving into cognitive science, neuroscience, architecture, and other such hot topics as have already been covered at the conference over the past 2 days. So welcome.
Thank you. Thank you very much.
Now, part of my preparation for today, I have read a little bit about you. Now, you didn't just stumble into research, one might say, but you certainly made your way based on curiosity and dissatisfaction with what we currently know when it comes to architecture. Is that correct?
That's definitely correct, yes.
Yeah? Can you tell us a little bit about how you came to study neuroscience?
Well, it's a funny story, really. I guess I have to sort of go back to my master's studies when I was still in the process of becoming an architect, which, of course, is a lifelong process, but in this case, I'm talking about my education. At some point, we had to decide whether we wanted to do an internship at a different studio than university. And I sort of realized that I did not feel comfortable actually putting down actual lines on a piece of paper that someone else had to experience, and I guess you could call it like insecurity, but in my opinion, it was like the lack of certainty in understanding the effect of architecture. It's quite interesting because once I then started looking up, what do we actually know about how architecture affects us? It's very weak evidence everywhere. In my opinion, you can discuss what we mean by evidence. But in the end, what I did was I pursued what you call a long master thesis, which basically consists of 6 months of research and then 6 months of actually doing architecture, implementing your research. And of course, I was faced with a lot of difficult questions. One of the first challenges was really to conduct research in architecture, because there is no real culture in architecture in terms of doing proper science research. Scientific research. We have a lot of philosophy, we have a lot of psychology, even architectural phenomenology, and we talk about all of these things, what it means to experience the world, and all of these very, very vague aspects. But in terms of the actual science behind it, it just still stands very weak. So once I started looking into it, I realized, okay, well, we don't know anything. And then the implementation of it into an actual project that I had to do, which, by the way, was a thermal bath in Iceland, turned out to be a very interesting project, interesting enough for my peers to think I should pursue a PhD. Then you know the story, yeah.
Yeah, because you've paraphrased Louis Kahn saying architecture starts from an immeasurable idea, then becomes measurable as a physical structure,
right,
and finally resides as an immeasurable quality.
Right.
And then how do we measure that quality?
That's you're asking probably the most difficult question in cognitive neuroscience currently. A lot of discussion going on, what do we really mean by the quality of anything? Is it really like the consciousness of anything? So the qualitative aspect of experience is inherently difficult to answer. And we don't even know whether the brain, for instance, is really the place to look. But we have really good reasons to start looking for it, perhaps there, to start from there at least, and then try to understand it from the inside out. So the experience of architecture is what I would call a composite of several functions that extend and have different scales. So I'm talking about temporal scales. Some experiences depend on the actual situation, and you can even expand the situation. So the temporal scale of the situation can be expanded into culture, which is many, many years. And you could even scale it down into all the way down to the actual interface between you and your environment, right? So that would be at the millisecond temporal scale. That is you interacting with your environment. Of course, experience also stems from that proper interaction, but we should not neglect also the whole history of our what makes our experience possible.
And just to, because you go from studying architecture and then you dive into neuroscience and the brain.
Yes.
So maybe just to pause at this point and help me, what is it? What is neuroscience? How do we actually research what goes on in the brain?
Right, so neuroscience is typically associated with brain imaging, right? So you want to you have participants and you ask them to solve some specific task that is typically related to what you would call a cognitive process. And then you would have variations, systematic variations, and you would look into how does the brain handle that, and can we image it? Can we provide some empirical evidence of it? And then we have different kinds. We have indirect measures, we have direct measures, we have single cell measures, we have so many different ways of looking at what's happening in the brain. So there's a local scale, a global scale, and all of these questions about how the brain operates. It's inherently complex. So that's like the neuroscience part of it. And I suppose, why did I start looking into neuroscience? So the brain is interesting for many reasons. I guess I could start from simple anatomical observations. So the brain weighs around 1.3 kilograms. It's about 2%, less than 2% of your average body weight. However, it consumes more than 20% of the total energy. I mean, just observing some of these numbers, it sort of reveals it's an important organ. It's not just random.
We need it.
We need it. It's definitely there for some reason, and this reason is really important. So I started looking into what exactly do we know about the brain, and even this question is incredibly difficult to answer. But one thing we know about the brain is that it processes a lot of sensations and a lot of motor commands. So it's perceptual processes and actions that we perform are all inherently related to the processes of the brain. But the brain, of course, is also attached to a body, and a body which is situated in a context and an environment. So eventually what you can do with the brain is look at sensory information, sensory processes, and how they're related to your actions in that environment.
So you can measure how my brain responds to, for example, entering a room I've never been in before.
For example, yes. You would be able to look at these measures of the brain dynamics. However, it always depends, what would you like to know about that entrance of that space? So you have to sort of phrase really intelligent questions in your way of approaching that difficult question in itself, right? Because you're talking about the experiencing of going into into a different space. The experience, as I said, is a composite of like multitude of layers. So it's really difficult to sort of figure out what does it do to you. So you need to sort of ask really intelligent questions and work with really intelligently designed paradigms.
Because part of what we've also been discussing and what has been presented previously during the conference within the topics of healthy buildings, we can monitor the temperature. Right. We can monitor light. Air quality, for example. We had Marilyn Anderson earlier today saying, of course, these are individually based and the variation is needed, etc., when it comes to light. But what you have monitored is actually how we respond to space. Right.
And spatial configurations. So basically, although I find all of these things very important, there are some individual variants that in itself becomes to me an argument that probably we should not just average over everything. There are some individual variants that we should take seriously, and they can actually account for a lot of the responses that we would otherwise find. Which leads me to the main maybe point here is that all of these simulations and models that we base our assessment of the building, we look at the performance of the building. In my opinion, this is maybe a little bit a red flag, I guess you could say, because perhaps it's not so much about rethinking that part of architecture. And apropos Build for Life, I think that life is arguably a biological process as well. And so perhaps we should take that part more seriously and maybe not just perform a lot of simulations on the building, but maybe the users who eventually will use that building. So we take a lot of, we make a lot of assumptions. So I should maybe also mention that I'm an engineer from Aalborg University originally, right, with an architectural background. So I have had these insights into the models that we use when we have to simulate, for example, the predicted mean value. We just assume how people would feel, how they would respond to this space in terms of the thermal comfort. And all of these assumptions, there are just so many of them, are all about the human being, and we're sort of reducing what it means to be human in that when we start doing these computations and predictions of the building performance. And I think that we're losing a lot in these predictions.
And I think a lot would actually agree. So what we've also seen as an increase is that we work a lot with post-occupancy evaluations.
Right.
So, and you know these as well in terms of the qualitative and quantitative methods whereby we actually ask the occupants about various aspects of the building.
Yeah, and I think that's perfectly fine. I think any step towards user evaluation, I completely support. However, I think that there are different kinds, different levels of assessments, I guess you could say. And speaking of Louis Kahn, going from the immeasurable to the measurable, and then back again to the immeasurable, when we talk about the user experience, we're talking about something that is very delicate and very sophisticated. It's not easy to measure the experience. It's in fact so difficult. You can't just simply ask people, and then they will tell you, well, yeah, actually this makes me feel really good. Yeah, well, I can give you at least 5 other drugs that can make you feel good. You should not abuse that. So asking people to do something, like, for example, do you like this building? How do you feel? Is it too warm? Is it too cold? All of these things, perhaps we shouldn't just rely on basic surveys in that sense. I think there are different levels of evidence.
Can you elaborate a little bit? Different levels of evidence?
Yes, absolutely. So I think, especially when you work scientifically, there are certain ways in which you should treat your question. I'm thinking specifically about the level of description in your question. You can ask behavioral questions, so you make behavioral measures, but you also need to be very aware of the way that you approach that, because if you're just going to make an exploratory study where you basically explore how are the users really feeling about this, and you're not asking a specific question, going with a deductive approach into this specific problem, then you might get what I would call weak evidence. It's evidence, for sure. Can't argue with that, but it's weak evidence, in my opinion. Sure, you can make an observation, your friend does something specific whenever something happens, and you go, interesting. But that's the point, right? Once you start thinking that something is interesting, you want to do a deductive approach, because then you need to systematically vary exactly that part, and that's when it starts becoming science. And essentially, we run into this problem of explanandum and explanans. What are you trying to explain, and what is the explanation? And there you have arguably a layer of different, what we would call today, fields or faculties. So you would have, for example, psychology, and what could explain the psychology? Perhaps it could be the physiology. What could explain the physiology? You just go deeper all the way down, so you're basically going in, you're sort of narrowing it down on the scale. And now I should also probably just say that I'm not saying that you need to understand everything from the lowest scale, because we learn a lot from the greater scales down. So that's top down and then bottom up. It's a combination of both. But the quality of your evidence definitely also depends on this hierarchy.
So when you started conducting your experiments, you actually did clinical experiments.
Right.
What was it you were trying to explore and identify?
So that's I guess I need to give you some background on some of these studies, right? So I was, just like I criticize a lot of architecture research and say that we're not doing real science in architecture and it's really bad, I feel that there was a lot of bad neuroscientific work. A lot of the neuroscientific work has to do with you sitting in front of a screen, and you are presented with some image, and then you click on buttons with your fingers. And then we think that we can say something about human cognition. We think we can say something about human memory, human attention, and the list just goes on with all of these human capacities. In fact, I don't like to use the word cognition. I think of them as capacities. So my critique eventually led me to sort of ask more ecologically valid questions. Can we figure out, especially in architecture, right? Because architecture is really incredibly complex to sort of work with, right? Yeah. So if you want to do a study of architecture, and especially if you want to go the neuroscientific way, you have to. I mean, there's a lot you need to plan ahead.
Yes.
It's not easy to measure what's happening in the brain while people are moving. That's why we always use seated EEG, or we use functional magnetic resonance imaging, and we use all of these different kinds of like PET, MEG. There's a lot of neuroimaging technologies, but they're always with the participants seated or laying down. And we even had an architectural study of people basically lying down in fMRI, looking at a small picture, and then they had to answer, do you like this or not? And then people had to click. And then the question is, well, is architecture a picture while you are lying down? Is that really the experience? So that's my critique of it.
So what was your question?
So my question was centered around the fact that we need to do more ecologically valid neuroscientific work in architecture. So I started looking into what we call the sensory motor brain dynamics, right? Because when you're working with neuroscience, you're working with very fast processes. You're working with down to 10 millisecond differences, right? So they can make a huge difference in your data. Just, I mean, all the way down to that level of scale. So what I started looking into was whether architectural designs could affect the sensory motor brain dynamics, which we know also has an effect on tons of other functions in the brain, right? So, for example,
how did you do that?
Well, it's fairly complicated. It's fairly complicated. So basically, what I do is I applied this method called mobile brain body imaging, and I combined that with virtual reality. So the reason I used the mobile brain imaging approach is that you have the freedom to let your participants roam around in your virtual environment. And I used VR because that gives me full control of the environment, and that's what you want. This is what I was talking about before.
So if I have to explain it to, for example, when I go home tonight and I say, well, I spoke to Zakaria, and what he did was, can then they say it's like a game? You had the respondents, your objects, part of a virtual reality where they could make decisions? Well,
so the experiment was about trying to understand how affordances. So affordances is basically just I have to explain that first. So it's a concept that explains how well your body fits with the interaction with the environment, right? Yeah. So a door, for example, affords going through. A handle affords being grabbed. This glass affords me picking it up. And all of these interactive, it's a relational concept. What I was doing was trying to understand whether that relation was reflected in the brain. Because that's my argument, right? My argument is that we essentially, the way we experience the world is an interactive process that happens between us and the building, right? So I'm trying to move focus here from the building to the user, and then again back to the building. Because once we understand that relation, we can go back from the user, which I'm trying to understand, back to the building, and then probably we could say something about how to build.
So you're trying to give us an abundance of knowledge that we can use in human-centered design?
Yes, exactly. Right. So this is fairly well formulated, better than me. It's exactly what I'm trying to do. I should also mention that these types of studies and whatever you want to sort of learn about the experience, it is fairly complicated, and that's probably part of the explanation of why we don't find it in architecture. Architecture is everywhere, and it's complicated. It's very, very difficult to say something specific about the effects of it.
So in clinical terms, I would assume that you have to clear some disturbing objects away to assess the sensory reaction in the brain.
Right, yeah, exactly. So basically, when we do our experiments, we use 120 square meters of free room, and people are basically wearing EEG, which is an instrument with which you measure electric activity from the scalp. So there's nothing like intrusive in that sense. And then they're wearing the VR goggles. And then I basically design the environment in a systematic way so I understand what causes all of these effects that I measure in the brain. Right? So it can only be one explanation. In this case, I worked with different doors.
What do you see in the brain?
Well, the brain is really complicated. We see a lot of things, a lot of ongoing, spontaneous activity in the brain. However, when you sort of try to average over the different trials your participants go through, we see that there is a different response whenever people cannot interact with their environment. So there's a lot of interesting points about that fact. So one of them is that the conclusion is that as you are perceiving something, you're immediately parallelly processing whether you can interact with it. And this really turns things around, right? Because typically the way we think about things is that we perceive the world, then something is happening, and then we figure out whether we want to interact with it or not.
Yes.
Right? But it turns out it's not really...
Yeah, we assume there is a sequence.
Right, and there is no sequence. This is this is the main point of that study. There is absolutely no sequence. You're basically figuring out whether you can interact with the environment, and that you're using that information in your perceptual process. So it's in a way you could say that the perceptual process and your motor, your action processes are inseparable. You're basically, the way that you engage with the world is in an active way. So this is one of the important conclusions of at least this one study that we are referring to here.
And if we tap that into, because I find that absolutely fascinating also, because when we talk about indoor climate and healthy buildings, one of the things that is that usually comes up in the literature is the anecdotal headache. For example, the air quality drops and a few hours pass, and then all of a sudden we have this headache that we can't explain, and then we go out, get some fresh air, etc. But what you're actually saying is that our body immediately responds to the spatial environment.
Yeah, I mean, definitely. So the headache part is way more complicated some of these than some of these studies that I'm doing, because a headache, I know, is a huge topic, at least in psychology and in neuroscience, trying to understand what are the underlying neural mechanisms of a headache, and it's fairly complicated, you might say. But in terms of what I'm doing and how to relate it to something like that, is that the well-being that you sort of try to cause using architecture. So when we think about healthy buildings and we talk about the health, no one really talks about the users. And I think it's fair to say that most of the research we see today is basically saying that they're doing healthy architecture and they're trying to create healthy buildings, but no one really showed any data of a human being. And I think that's very worrying. So in my opinion, we should really rethink what we mean by health when we talk about healthy buildings.
Okay, and by that, so basically I know when we talk about healthy buildings, you are then, I can infer from what you're saying that you find that there are a lot of assumptions behind it.
Right, this is the issue.
Yeah, which assumptions do you think that we need answering?
Oh, well, I think
or do we need to have some different assumptions?
Oh, yeah, that's for sure. So the whole idea about assumptions and the way that we perform, when we look at the building performance, are basically typically human assumptions. It's assumptions about the human being and how the human being will use that building. I think that it's fair to say that a lot of these assumptions can be easily dismissed. And
give me an example. It's always good to have examples.
Well, I actually like to think of for example, the engineers. They work with these prediction models of how people will feel this thermal comfort, and we always aim for the 80% level of comfort because we can't explain the last 20. I'm thinking maybe the last 20 could be psychological, and it could be about how you interact with your environment. I also like to think that now you have a lot of, so this is a different example, you can get a lot of certificates out there in the building industry where you now know how to do a specific simulation of a building. And when you look into these simulations of the building, you can get scores based on how many pictures you have hanging on the wall. And I think that has to do with social sustainability, because we don't just hang pictures on the wall to loosen the headache. I think there are other reasons, and I think they're highly psychological and inherently human reasons for that. So perhaps some of these things should also be taken a bit more seriously than just hanging pictures on the walls.
And a healthy building to you would be then what? Should we even use the word? Is that what you're saying? We need to coin buildings, call buildings something completely different? Or can we use the notion of a healthy building?
I think we can, but we need to be very clear about what we mean by the healthy building, because at this point, I thought that healthy building was, when people talked about it, that it was about the human health. But it's much more about the health of the building, the actual building, like the physical substance, the building. But what do I define as a healthy building? It's a building that is based on the human principles, on the human principles of interaction with its immediate environment, with the world, and the way that we build. To me, this has much more to do with the human health in that building. So I guess that. Well, there are so many things there's so much room for improvement, in my opinion. And you shouldn't get me wrong, because I'm not saying that we shouldn't do all of these simulations. We shouldn't. I'm not saying that we shouldn't work on daylight and stuff like that. But I think that we need to add something to this. And this is where it becomes really tricky, in my opinion, because once you start adding things, you sort of figure out that, okay, someone did a study figuring out that room heights actually improved people's sense of well-being in that space. And you go, okay, well, we want to do sustainable buildings, right? So the way that you build is very, let's say, you're very aware of the materials you're using and how much of that material you're using. But then you have studies showing that you need more room height. So let's imagine a fiction project here. You have a skyscraper, you have 50 floors in that one, and all of them has just barely 2.10 meters from the ground to the roof. But then someone comes and tells you, well, social sustainability and so on, and goes like, maybe we should add a couple of more meters to that, but then you will lose a couple of floors.
But just to clarify, because social sustainability is not the same as health, or is it?
I think, no, they're not the same, but it has to do with sustaining healthy components and factors of a human being, right?
Say that again.
So I think I would unpack it. It's much easier. Health is something that needs to be sustained. It's not something that just comes out of nowhere. It's something we need to take seriously and treat it. So when we talk about social sustainability, we talk about creating an environment, at least in architecture, we're talking about creating an environment that is mentally healthy and it's also emotionally healthy. We have plenty of examples of horrible architecture that are causing very, very serious disorders, psychological disorders, anything from living close to monumental war monuments, causing actually higher depression, higher chances of getting a depression, anxiety, and all of these things. And it's basically just modulating the environment, right? So basically, the health part of social sustainability is something that I think we should take more serious, especially the mental well-being.
Okay, so you do, just to clarify it, so we do have research that can document a building's impact on mental health.
We do not have proper tools to do this. This is my issue, right? And this is why I do this research that I do, because we do not have tools to simulate human beings just as much as we can simulate buildings. They simply don't exist, and this has something to do with the history of architectural research, but they were never really about human beings. We have a lot of tools to analyze the surface of the building and how much material is going to be used and the thermal comfort and all of these things, but we have very few, and those few are very primitive, of the human experience of the space.
So we have a lot of knowledge and research that can document a building's performance.
Right.
And we have the tools and methods for that.
Right.
Good. So far, so good.
Yeah, well, with the buildings, right? And then
with the buildings.
Right, now we're missing what I think is perhaps equally as important as the building, which is the user. So what I'm basically saying is that we do not have enough research to create some of these tools. We simply don't know how people would respond. And that has to do with people being fairly unpredictable in that sense. There's a lot of cultural biases, a lot of local biases. There are so many parameters in understanding human beings. But I think that it's possible to sort of figuring out what factors are the most important ones. Because obviously, certain factors has a higher impact on us than others. So I think it's our job now as researchers to sort of figure out what are these parameters and how can we try to simulate them?
Okay, we have a question from the audience.
Yes.
Thank you. Besides daylight and room height, what else improves human well-being in architecture?
Oh, that's a great question, fabulous question. I have two answers to that. The first one is that the affordances. So basically, in which way you are allowed to interact with the environment. What kind of, let's say, narrative does the environment or the sequence of spaces allow you to have? Right? So this is something to do with you are basically always invited to do different things by the environment. Stairs, they invite you to climb them. Chairs invite you to sit down. If you can create all of these different you basically have a landscape of affordances, and this is basically what architecture is, in my opinion. It's an interactive, it's a relationship between the user and some built physical substance. So one thing is to look at how people can interact with their world. Is certainly one thing that we need to look at and take much more serious in architecture research, right? We know that from prisons, we know that from schools, we know that from many, many places. Yeah. My second answer to that is also that I don't know. I simply don't know.
So that's why when you had to choose between doing the long master and the internship, you did the long master. There are still things we simply don't know.
Yeah, well, I can guarantee you that now, even as like 6 or 7 years after my first crisis, I still can't answer that question. And I think it's a beautiful question, but I simply cannot answer it. We don't know enough about it.
And what did you identify from your experiments in the room with when you conducted how the brain responded? What were you able to identify from that research?
Well, a lot of things, actually, because that data set is, by the way, also freely available online, so everyone can sort of grab that data and run different kinds of brain analysis if that's what they want to do. But from there, we learned, for example, that the whole question about perceiving architecture has a lot to do with how you can move in that architecture. So the movement factor here is apparently extremely important for our perceptual processes. Yeah, well, if you want to talk about our perception in architecture, you need to consider movement in that space, because apparently this is what the brain is interested in about, right? So a second, yeah.
You have to give me a concrete example. So movement, right. That it's important to be able to move, or that the brain responds in navigating in the room and its trajectory.
Well, I probably would have to bring up the teleological argument that you're always on your way to do something. So you always have a goal, and your way from where you are now to that goal is defined by a sequence of actions. And I think I will just leave it at that, because then people will realize that how much impact architecture has on us. I'm talking about simple goals as I have to go to the grocery store today. There's a sequence of interactions with the environment that you're already planning, and these are happening in the brain. Yeah, and this is where architecture sort of comes in, because it can modulate that and change the state of the brain, which will then affect all other capacities you have, including short-term memory, long-term memory, attention, and all the list goes on.
And that's why I also opened with your own sentence in terms of architecture designing the quality of life.
Right, this is exactly what it is. Yeah.
We have another question, and thank you very much. Keep them coming. I'm thinking about how biomimicry can add to our feeling of well-being at a grander level, as you describe, on mental healthy building that are intuitively better.
Yeah. Okay, that's an interesting thing. I think I will stick to the point with biomimicry and how that can add to that. I think biomimicry is interesting as a study in itself, but whether it applies to the mental well-being of humans, to my knowledge, there are no scientific studies of that at a physiological level, right? So no one is trying to explain why that is and how that can be that we have some kind of relation to the mimicry of biological features. So. Another thing is that, for example...
because sorry for interrupting, but you actually told me that in part of one of your experiments,
right,
that you documented that too much wildness actually scared the brain. You could document that the people actually got afraid.
Right, and it's really interesting because, so that's...
Or insecure, I don't know what would be a more correct term.
Biomimicry should probably be dissociated from biophilia, which is basically being exposed to what people just simply call nature. And no one really knows what that is, because what is not natural in here right now? I think everything is made of natural resources. But then people would refer to the greenery. But then there's the question, should it just be a plastic plant or an actual plant? And there are so many things. What about the composition of it, the size of it, and all of these things? And these things are really, really delicate. So what we did was that we tried to figure out we took that the theory and sort of turned it to the extreme, because that's essentially what biophilia would say, right? It would just say the best environment is the unbuilt. You basically have to live in nature if you take it to the extreme. So basically what we did is that we seeded people in VR in different kinds of nature. And we found that, so this is actually unpublished for now, and it's going to be published very soon, that you can actually stress people even more by exposing them to wild nature, simply because it's unpredictable. It's unpredictable, and too much of it can, in fact, cause the exact opposite effect.
So we need a level of predictability for our well-being.
Well, yes. So the brain is basically, the way that I work with it is as a predictive organ. It's an organ that is trying to circumvent possible bad things, let's just say, before they happen. Because if something bad happens to your body, it's simply too late. Now you're suffering the consequences of being wrong in your predictions about the environment. So the predictions are inherently important to the way that we interact in the world. That's also why we have to think about affordances. Affordances are embodied predictions. They are basically predictions that contain the body as a physical structure, as a parameter. And that's the important part.
So part of my well-being is also the ability that I can predict my future movement.
Yes, exactly, right. So a recent study, for example, showed that in major depressive disorder, you have a depressed sensory-motor connectivity in the brain, which basically means that this person probably doesn't know exactly how to use the body and sensations to cause certain actions. And from that, you can learn and you can create a very speculative hypothesis. Could it be that the environment is simply not fit for that person? And I'm not saying this as a cure to something like a depressive disorder, because that's a very, very serious disorder, and architecture can in no way cure it. But I do think that the environment can be a support, and I think this is very important to emphasize.
Because yesterday we actually heard from one of the debates that in a survey that 30% of the respondents in a survey did not feel connected to their community. And I was thinking in terms of our talk today, the difference between health and well-being and also connected to community, that we're using a lot of different phrases, and are they in some way confusing the matter? Do we need to clarify it a little bit?
Well, I think that clarification is always needed. So definitely call for clarifications in the way that we talk about health and well-being. But I should probably also emphasize the fact that health is also a term that a lot of, it's basically spread across all kinds of scientific fields. A lot of people are talking about health in different ways, so it's always, you probably need to talk about what you mean by health. In my opinion, it's a start to ask people, how do you feel? It's a start, you shouldn't go back from that. However, I would like to see people taking the next step, trying to understand why that is, that they are feeling better.
To explain it.
Exactly, so that's back to the problem of exponence and explanandum,
Because we have a question in terms of, can you really measure reaction to nature by using VR simulations? I think there's a huge difference between real trees and computer-generated trees.
Oh yeah, I completely agree. So this is one of the limitations of the study. It's very important that I mentioned that this was done in VR, yes. However, who would like to try to explain the variation that we find? I'm just, then it's a challenge, right? Then what is that variation that we find? It must be something. Maybe it's pixel related, because that's eventually what VR is, right? Perhaps it's not. So I invite everyone to do these kinds of experiments. I think that we have too few of them, and we simply don't know about the whole biopsychological framework of architecture. We simply don't know about the biology behind the psychology.
Following up on the VR, we have a question. What other methods besides VR do you think will give us good information about human response to architecture?
Yes, I think that's an excellent question, and something that we are wrestling with a lot right now at Aalborg University with Professor Ole B. Jensen. We created this group called Situated Mobilities and Sensing Bodies, because we sort of want to now try to move away from the VR lab and into the actual urban environment. So we're sort of trying to now marry the idea of neuroscience and architecture with mobility studies and urban mobilities. And I think that VR is a good start. However, I think the next step would be the combination of EEG, mobile EEG, with AR systems. Because, and this is going to get really tricky, because what do you want to do with the AR? Well, you need that to create some kind of psychological paradigm of the function of the brain that you're trying to understand better. So let's say you're working with memory and you're working with dementia. Then a AR system would be a much better solution than the VR system for many reasons. Also in terms of the weight of the equipment and the patients are typically kind of fragile, and you shouldn't put too many things on them.
Yeah, because you have the ambition, together with Ole B. Jensen, actually to explain movement, mobility in urban space, in open space.
I think it's too much maybe to say that we try to explain it, but we're trying to explore what exactly is going on, what kind of communication is going on between the brain and the body, and then the body to the environment.
Because at this stage we still know so little.
We simply don't know anything.
We have another question. What is your opinion on the fact that when considering thermal comfort, our standards are still based on the average male's comfort temperature?
Right, I think this is horrible. In fact, yeah, I like the fact that they mentioned male. I think that there's a lot based on the male body. It's very, very evident in the urban scene. In fact, you can see bus stops, you can see open squares, you can see passive facades. There are so many things that are not made for anything but a male. So yes, I think that's horrible. I think there is I would call for a change. I think that it's very important that we try to be as inclusive as possible. Otherwise, it's not worth the effort, in my opinion. So both the fact that it's a male and the fact that we're using averages of across the whole nation, the whole world, actually. Speaking of that, there is this, let's say, crisis in science, where we talk a lot about the weirdness of our data. So weird stands for Western, educated, industrialized. I can't remember the last ones, but you can look it up. And basically, most of our research is based on that. We mostly know about young German students, because that's the people we take in for our experiments. We simply don't know if this applies to other places in the world.
So because what is actually, usually some of the more stark critique of neuroscience would be that it can explain, it can predict behavior. But part of what we have also been discussing is that you actually want to be able, you have a huge interest in interaction and enactment. You actually believe in the actionable agency of the individual.
Right, exactly, yes. So I think that's, you're touching upon a very, very complicated topic in neuroscience, and I think that neuroscientists has for very long tried to explain behavior, but I think that we always sort of we fall short for it, let's just be honest. Perhaps what is the computation part of neuroscience, or computational neuroscience, is probably a bit better than the empirical part at explaining, not explaining, but simulating behavior using different kinds of neural networks. You can get quite precise models, and even these models have their limitations and are flawed to some degree.
Because we have this wonderful question. Users not involved, how do you integrate research insights in the design process and final design solution? Because that's actually your ultimate goal, is to be able to do that, right?
Yes, absolutely. So speaking of Louis Kahn in the beginning, right, and how little we know, I still insist to say that we simply don't know enough about the impact of architecture on the human beings, and even the integration of that knowledge is the next step that we sort of need to look at. We need architects to take that part more seriously. I think that architects need to run more simulations based on users. That would at least create some kind of integration, include them in that process, and not just behavioral. You can also do VR studies and invite the clients and all of these things. But I also think that simply because there are no results at hand, you can't just, I mean, if you're an architect and you don't get thrown, you don't hear results, you just don't know that they exist. So it's also about communication, for sure.
And maybe I think it's too hasty for me to say, but part of what you've also been explaining and exemplifying today is the huge impact technology and our technological innovations in terms of research methods have been able, or applications have been able to contribute. Yes, absolutely. So the technological development is something that we are dependent on.
probably also one of the reasons that there are not so many of these studies is because it's fairly complicated to do these things. And technology is developing. It's a bit slow, but we're getting there. We can create more and more sophisticated experiments, and we can get more sophisticated answers.
Yeah.
So sort of to come back to the prior question, I think that it should be like one of the goals of my research is essentially also to have an impact on the policy making, because I think that we are actually at that level of seriousness of this kind of study. You can't just neglect the social sustainability. You need to feel comfortable in a space, and we are starting to figure out and unpacking how that happens.
So the ultimate goal is actually to have so much rich and saturated data that we can influence the political regulations in terms of how to design urban spaces and buildings?
I think that's extremely important, because otherwise it won't get out there and people will just, pick and choose and sort of pick that out because it costs a lot.
We are running out of time, and there's praise from the audience saying thank you very much. And you have 2 seconds now to say, because I promised you that given the lack of knowledge, what is your wish list? Christmas is coming up.
Yeah,
what is
Christmas.
it that you would like to know?
I guess my wish list is that maybe my first point is that I wish that architects would take the human more serious, especially when they talk about human-centered approach, and just stop covering it up with these nice words of health and all of these things, and actually just take that step. I think there are good architects out there doing that. A second point is that I think that also funds need to take that a bit more seriously. It is a bit hard in research to do these kind of things, because what are you, a neuroscientist or an architect? Well, can't you be both? I don't know.
It's a beautiful wish. We need to take human beings more seriously.
Yes.
On that note, thank you so much for joining me today, Zakaria.
Thank you for inviting me.
It's been a huge pleasure.
Thank you.